So good afternoon, everyone. This is the second in our series of kind of the revised Tech Talk series. And I've got an extra special presentation for you here today. Our friends from University of Buffalo, Tom Furlani and Joe White are with us. And they're going to give you an overview of the XDMoD system monitoring software. It's, you know, at the surface, that's its function. And it turns out there are a lot of other interesting aspects of this project. And rather than me trying to muddle through it on a Campus Champions call, we were fortunate enough to get the guys to give us a presentation. So I've been following this for a while now, and I'm extra excited to be able to bring this to our Campus Champions community. I think you're going to see a lot of things you really like, and I hope many of you will be in a position where you can give this software a try. So without further ado, I'm going to go ahead and hand it over to Tom Furlani, the director of the University of Buffalo High Performance Computing Center. Tom?
Okay, thanks, Jeff. And so I thought, first of all, I appreciate everybody taking the time to hear our presentation, and it's a great opportunity for us to kind of talk a little bit about what we do and how we think it can help you. I know one of our campus champions here at the university, Cynthia Cornelius, who's on the phone. She uses it pretty much every day, and so it helps her do her job. At least I think that's what she would say. And just wanted to give you a general overview. So I'm not going to talk very long. I have about 10 or 12 slides. And then I think the most useful thing is for Joe White to give you a demo in real time about some of the features it has. Not all of them, because it does quite a bit. And but to give you an idea of how you might use it in your workflow as a campus champion and as an HPC support specialist. So the overview is I'm going to talk a little bit about XDMoD in general. There's two versions. There's XDMoD without the open in front of it, and that refers to the version that runs on XSEDE resources and monitors all the service providers that provide service through the XSEDE portal. And then the open source version is the version that runs at HPC centers. We run it here, and it's called OpenXDMoD, and it's probably installed at more than 250 centers worldwide in both industry, academic, and government. So I'll talk a little bit about the portal, and then the two other areas, measuring quality of service with application kernels. And then Joe's going to spend a lot of time talking about how you use it, the job viewer, to measure job level performance. And that's the thing I think Cynthia uses it primarily for. And then a summary. So how did this come about? We like to think of XDMoD as a comprehensive tool for HPC system management. It stands for Net Service. It's part of a Metric Service Award that's an ongoing program with the National Science Foundation. I got a little ahead of myself. XDMoD itself stands for XD Metrics on Demand tool. Years ago, we used to have something called UB Metrics on Demand, and as part of the XSEDE program and as part of the National Science Program, we rebranded it with XD Metrics on Demand. So what is the goal? It's to optimize resource utilization and performance, and that can happen in a bunch of different ways. First of all, you want to know who's using the machine, how much they're using the machine, what is the historical. There's other systems that do that, but we also provide that information. Then you'd like to make sure that the hardware that you're running on is actually performing at a high level, and so we develop tools to measure quality of service. I'll just briefly discuss that in a slide. And then, like I mentioned before, the thing we'll focus most on is how do you measure and improve job and system level performance. And then we can use this tool, we use it here to inform computing system upgrades and procurements. You can know how much of your memory is being used at any one time, what type of applications are running, those sorts of things, and how much memory they use. And as I mentioned before, there's an open source version, OpenXDMoD, and that's used for data centers in general, open source. And it's, like I said, 200 or plus academic and industrial installations worldwide. The link to it is there, and I think Marissa is going to make this slide deck available to everybody. So I like to think of three primary components of XDMoD. There's the portal itself, that's the interface that we have. There's the application kernels, which measure quality of service, and there's the job viewer, which measures and allows you to improve job level performance for every single job that's running on your system. In terms of the portal, Joe will go over this in greater detail, but it's tab-based. You can notice, hopefully, and you can see that there's tabs across the top of that. There's a summary usage, Metric Explorer tab, allocations, application kernels, and others. There's a custom report generator, which allows you to get to decide what reports you'd like to receive and say how often you'd like to receive them. And then you don't have to log into the system. Like for myself, as center director, we have a template, which is a center director template. And so I get a copy of that report every month, and I look at, it's emailed to me as a PDF file. And so then I can look at the overall system performance or utilization without having to log into it, although I do log into it fairly frequently. It's role-based, so if you're a center director, you see globally. If you're a user, you see your usage. If you're a PI, you see not only your usage, but also the people that are working within your group. And so, for example, you can very easily attain CPU hours consumed by various campus units, in this case, School of Engineering, College of Arts and Sciences, and it allows you to generate pie charts, column charts, bar charts, line charts, but it's pretty easy. I can then click, for example, if I were to click on the blue School of Engineering and Applied Sciences in that pie chart, I could then drill down and get, I'm sorry, this is a plot of by the engineering department. Yes, I could get the utilization by the various engineering department, both in terms of the number of jobs, which is the red line, and in terms of the CPU hours consumed, which are the blue columns. So it's very easy to, you see there, I just click on the blue, and then I can drill down further. I can add additional data to it. I could drill on any one of those departments and see what are the PIs in those particular departments that are using, contributing to those CPU hours and jobs.
Tom, this is Marisa. There's a quick question in the chat box that says, what's the difference between XDMoD and just pumping all these stats into Splunk, or an ELK stack or equivalent metrics program?
I'll let some of the others, my quick answer would be that, and then I'll let Joe or somebody else chime in. But so we can not only look at utilization, but we can look at, first of all, the quality of service, which I'm going to mention here in a second, which looks at the performance of the various hardware and software components that make up your cluster and tells you how well things are operating. And I'll give an example, 2 examples of that. In addition, we can look at the performance of every single job that's running on the system, and we can look at the performance of that job in terms of cache fill rates, in terms of CPU user, in terms of a lot of other performance indicators. And a lot of those, there's no one tool that does all those things. We try to integrate all that functionality into this particular tool. Does anybody else want to add to that that's sitting in the room?
Yeah, I mean, I suppose one of the main advantages is that we're coming at this from the point of view of monitoring an HPC resource. So we've thought about what information you want about that resource, how to process it correctly. We have already the infrastructure in place to directly hit the resource manager logs and then take them into the interface, manipulate them in the correct way to present the information that you need. Of course, you could do the same thing in Splunk or ELK, but you're going to have to write a lot of that infrastructure yourself and your custom queries yourself that we've already done the work for. And then, as Tom's just about to talk about, things like the quality of service metrics in the application kernels, the existing metric stores are not going to be able to do that for you. There's a whole load of infrastructure that we've put in place already that allows you to do that. So,
and the other thing, it ties into your university's hierarchy. And so you get decano units, you have to enter that in. But so, for example, if my provost says, I want to know what decano units utilization is, and what for each of the decano units, which departments are using it and what PIs are using it, that information is available because we built that hierarchy into the software. I don't think that that's available in Splunk and ELK. You'd have to build that all in. So anyway, like as Joe mentioned, I think the best way to say it's been designed for an HPC system, monitoring and performance. Any other questions?
There's another one in the chat box that says it would be nice to be able to track GPU utilization and GPU jobs on the cluster. I've seen some hacks mentioned on the forum. Is there any plan to add GPU support?
Yeah, so if we're referring to the open source version, if you're all using the recommended software, which is the PCP data collection software, we already have the infrastructure in place to collect the GPU metrics. So if you're using the open source version that's released already, you can view like the GPU utilization in the job viewer as it stands at the moment. What is not in there yet, but will be added, but it will probably be waiting for the 8.1 release, is doing things like viewing GPU utilization metrics in summarization form in the Metric Explorer. Of course, now that answer just assumes that you know what all of these things mean, right, but hopefully, I'm assuming that the question didn't know that. Now, in terms of the XSEDE version, so that's the software that we host here that displays information about the various XSEDE resources. We have GPU utilization information available where we get it from the service provider, which is a little bit more patchy. I think we only have it from Bridges GPU at the moment.
But basically, we run GPUs here, and so we're like you, we want to know, are they actually being utilized, and are they being utilized efficiently? And so we're very interested in that, and on the open source version, we can keep track of that. That's our intent. And as Joe mentioned, and you'll see in a slide or two, we run Performance Copilot, which collects a lot of that information. But I'm getting a little bit ahead of myself. That's coming up on the next 2 slides. Any other questions? Okay, so I'll push on. I want to leave a lot of time for Joe. So the other thing we do, we look at the quality of service of, these are complicated devices. They have memory, they have compute nodes that's attached to storage, it's attached to a high performance network, and you're never sure that it's all operating efficiently. As a matter of fact, a lot of times our users are the ones who unfortunately point out some of the problems we have. And so we run these things called application kernels, and they're basically snippets of codes. In some cases, it might be a quantum chemistry code like games, where we've taken a small test case and we run it. We want it to run pretty quickly, but also be able to measure the performance of the system, whether it's the file system, whether it's the CPU, whether it's the network. And so we have a series of application kernels. We selected them to kind of span the entire operational characteristics of the machine, but they're computationally lightweight. We run them very periodically, though. Some run every day, some run every other day. And we want to measure the system performance from the user's perspective, not from the system administrator's perspective. The idea is you want to proactively identify underperforming hardware and software. So in the example I'm showing to you is a case, it's Stampede, TAC Stampede, and it's a file system. So on the y-axis is the megabytes per second, and on the x-axis is the day. And so you can see higher is better than lower. And so all of a sudden at one point, the file system performance fell off. TAC was aware of that, but we were able to identify that as well by running these application kernels. It turns out that they did something on a system-wide upgrade, and then they had to go back and figure out why it impacted the file system performance. But these application kernels, the nice thing about not only looking at the performance of these various application kernels, since they run every day or pretty close to every day, we know when the problem occurred. And for example, we had a case where we did a firmware upgrade on our switch, one of our switches, and it caused the parallel file system performance to be degraded pretty substantially. It turns out we knew exactly when that happened, and we knew what we did on that day, and that was the firmware upgrade. If we weren't running these, we would have probably noticed the file system performance fell off a month later, 2 weeks later, and we try to figure out, well, what happened over the last month or so that caused that performance. But since we run them every day, we could pinpoint the exact time at which that performance degradation occurred. The next example is one that kind of hits a little closer to home, and so you're all familiar with the Spectre and Meltdown vulnerabilities and the patches that Intel put forward to mitigate those. Well, those patches have performance impacts, and so because we ran these application kernels all the time, we installed the patches, and we were able to in very short order determine what the relative performance impact was for those patches that were put out. And there was a paper that we're in the process of writing a paper. There's also it appeared on HPC Wire. But if you don't have that information, you have to go back and try to rerun everything and then measure that. It's a time-consuming process. And then the last thing I'm going to talk about before turning the keys over to Joe is, and I think the thing that's probably the most interest to this group, is measuring job-level performance. So it's an integration of XDMoD or OpenXDMoD with various monitoring frameworks. So you may be familiar with TAC stats. There's also something called Performance Copilot, which has been around a long time. Silicon Graphics started it. It's now maintained by Red Hat, and it's called PCP. So we run PCP here, and most of the service providers in the XSEDE framework run TAC stats, although I think Bridges runs PCP. You can choose whichever one you want. We run PCP here because it has some additional functionality that we use, as Joe mentioned, the GPU. And I just wanted to point out, for those of you that didn't have the good fortune of knowing Jim Brown from the University of Texas, this was his pioneering work on performance monitoring. And sadly, he passed away this year at the good old age of 84, 85 years old. But anyway, I just want to acknowledge his contribution to this. The thing is, we run this Performance Copilot. It runs on every node within the cluster, and it collects hardware counter data. We've looked at the performance impact this has, and we've not been able to measure the performance impact. We collect data every 30 seconds, although you don't have to collect it that frequently, but that's what we chose to do here. It keeps track of CPU usage, memory usage, I/O, all those sorts of things. And what it lets us do is identify poorly performing jobs. And as Joe's going to show you, you can do searches for those, and you can determine what your criteria is for a poorly performing job, and then identify all those jobs that have that meet those criteria. But the plot that I show you here is the CPU user percent. So you'd like to see things at 100% versus time. And in this particular application, this is a real world application that ran, I think, at our center. Out of 7 nodes, 1 node was doing useful work, was running flat out at 100%. Unfortunately, the other 6 nodes were just sitting there not doing anything. So that's not the best utilization you can have of your HPC infrastructure. Matter of fact, we had one case, which is the gold standard for poor performance. Somebody was running a sequential code on 40 nodes, and so they were using 1 core on that 1 node, and the other 39 nodes were doing nothing useful. They just didn't know it. It's not malicious. Their background was not in computational science, and they inherited a code, and they thought it was parallel, and they said, well, if it runs well on 1 node, it'll run really well on 40 nodes. So you want to identify those types of poor utilization. But if you ask most HPC centers, a lot of them, what's the application usage? A lot of centers, we couldn't, before we had this program, we couldn't tell you what the highest running applications were on our particular center. You get that for free with the things we do here. So you can identify the node hours and the number of jobs and break it down by application. And then Joe's going to talk about this. This is the job viewer, and this is something Cynthia uses frequently. And I'm not going to go into a lot of detail here, but we have these traffic lights along the top. This is a particularly poor job. One of the servers had a failure of a network process. I think it was the InfiniBand controller hung. So out of 128, I don't know how many nodes were running, it was happily chugging along at 100% utilization. All the other nodes in that job were hung and weren't doing anything. And so along the top, you see the traffic lights, the 3 of them. Joe's going to talk a little bit more about those, but green is good, red is not so good, and yellow is kind of in between. So you can see this particular job had a lot of red. The CPU user was 0.064 instead of 1, which is not very good. But again, it's a way to drill down and find out information. You can enter just the job ID, and then for that particular job ID, if you're sitting with the user, bring up and get detailed information on their particular job. And I'm not going to spend a lot of time on this other than to show these are just various plots taken from the job viewer. You can look at memory usage, you can look at CPU user, and these are functions of time, flops and L1D cache fill rates. And the take-home message in this is that one of the nodes reached its memory limit and it fell off. The other nodes kept chugging along, but it wasn't a productive job, and so you were wasting all those CPU hours that the nodes were tied up when one of the nodes had already failed, and so the job failed. But the job didn't know that, so it just kept running. And the last 2 slides, I think, are, again, this is the people that are responsible for developing the software, and it's a collaborative effort between the Center for Computational Research at the University at Buffalo, and as I note there, Cynthia Cornelius, who's the campus champion. She's the one who's telling us everything we should be adding to the job viewer to make it better, and sometimes we actually get to the things she asks us to do. And then Indiana is doing the scientific impact work, and Bill Barth and Todd Evans from TAC are doing a lot of the stuff with job level performance data as it applies to TAC stats. And we're thankful for NSF's support. And I think that was my last slide. So while I'm going to turn it over to Joe, we'll be happy to take any questions, and then Joe's going to go ahead and do a demo.
Any questions while Jeff's setting up? Feel free to add to the chat window, or at the appropriate times, go ahead and break in and ask your question. But we certainly are anxious to have questions from the community.
Okay, well, yeah, thanks, Tom. I'm Joe White, and I'm just going to now go through a live, it's always risky doing live demos, isn't it, in these things, a live demo of our the production XDMoD instance that hosts the data for XSEDE. So it's a web-based interface, loaded up Chrome, but any modern web browser will work. Quickest way is probably just to type XDMoD into your search engine. And in fact, the top two results, the top result is for the open XDMoD software. So that's the software that Tom was talking about, that you can download. It's GPL software you can download, have that installed on your center, and have all of the information hosted by you at your center. And then the second link is the XDMoD software, which is actually the instance that we host at CCR that has all information about the XSEDE systems. So click on the link, you're presented with the main page, which is shows the publicly available information. There's a summary charts on the front page that show things like the number of XDSUs charged over time by the different resources in XSEDE, and several other plots. On the top left-hand side, there's a sign-in link, and if you click on the sign-in link, dialog box, and you can sign in with your Globus credentials linked to your XSEDE account. So you click on that link, and you will be presented with a Globus single sign-on page. You can log in using your organization credentials. I'm going to use my XSEDE credentials. You also could use your XSEDE credentials to log in. Click continue, you get to the XSEDE page, type your XSEDE credentials in, click sign in, wait a few seconds for the inter-process communication, and then you'll be logged into XDMoD. So I believe that all the folks here are all XSEDE campus champions, so you should all be able to use your XSEDE credentials to log in and get to the interface very similar to what you see here. The main, okay, so I'll just talk about a couple of the main features of the interface, and then we'll go into a little bit more detail about different things. So as Tom mentioned, it's a tabbed user interface with a set of tabs across the top. And the keen-eyed amongst you have noticed that there are now more tabs available across the top than there were available to the public user. There's also information in the top right-hand side, and the key two things I wanted to point out in the top right-hand side is this help icon, where you click on that, you get a drop-down box with a link to the user manual, and the user manual has all detailed information about how to use the various aspects of XDMoD. So you can look at this in slow time and actually see it has a few step-by-step guides about exactly how to do different things within XDMoD. The other main thing that I wanted to point out is this contact us box, where you can click on send message, and you get a dialog box come up and you can type a message in. Now, the reason why I want to point this out, well, two things. Firstly, we actively support XDMoD, so you can send us support requests, you can send us questions, and we have multiple folks on the team here who spend a lot of time each day answering these questions and making sure that we support this stuff very well. The main reason I wanted to point this out is that for the folks who are campus champions, when you log in with your XSEDE credentials, you'll be given by the within our instance, we don't have an automatic way of knowing that you're a campus champion. You by default just get the access credentials of a normal XSEDE user. But if you log in and then do a send message and tell us I'm a campus champion at this campus, then we can make sure to go in and add the correct credentials to your account so that you can have access to the information that you're permitted to see. In particular, all the information about the low-level job data and job performance data for your campus. So you can go in, log in, click on the Contact Us button, send a message, just mention who you are, what campus you are, and then we'll be able to we can have folks here who will go in and make sure you have the correct credentials added to your account. So the user account that I have logged in with has credentials, so I can see all the various performance data, so I can demonstrate it to you. So I think I'll jump straight into the job viewer. So on the top right-hand side, the job viewer tab is located on the top right-hand side of the interface. And we click on it, and you're presented with a a blank page by default, which will show an image showing you what to do. So the first thing I wanted to show off is just how you would go about searching for an individual job that ran on one of the HPC resources that you know about. So typical scenario where you might do this, if you received a support request for a user, they say, I ran a certain job on given resource, this was the job ID, and I had a problem with it, please can you help me? So what you can do, click on the search button on the top left-hand pane, and you're presented with the search dialog box. And the quick job lookup allows you to quickly look up a job if you know the result, if you know the job ID. So in this case, I'm just going to pick an example job that I know is in the system. Click on the drop-down box and pick the resource, in this case STSC Comet, and then type the job ID into the job number box and click the search button. And what that will do is that will bring up the results pane on the right-hand side. Now, since this is a single job lookup, there's only one job with that ID. It brings up the jobs that it's found in the database. And on the bottom right-hand side, there's a button that says Save Results. You click that Save Results, and then it will load that job into the search history pane and the main interface. So you click on the left-hand side of the main interface and click on the job identifier, and then it will bring up this tabbed interface that shows information about this particular job. So the main aspects of this interface, as Tom mentioned earlier, there's across the top, there is what we call sort of traffic lights, which is our summary view of a selected number of performance metrics. In this case, the 3 different performance metrics are the CPU user balance, which measures how the relative usage of the different CPUs in the multi-core job, homogeneity, which measures how uniform the job was over time, and then this overall average CPU usage, which says how much the CPU usage was in the job. Now, of course, we're not going to necessarily remember all this. In the top right-hand side of all these boxes, there's a little question mark. When you hover over that, it will bring up a tooltip that explains exactly what the metric is and where it comes from and what it means. And as Tom mentioned earlier, red is the way we've color-coded this is that we've tried to normalize these metrics so that 0 is bad and 1 is good. 0 is displayed usually in red and 1 is displayed in green. So in this case, this job happens to have fairly low average CPU usage and low homogeneity. So on the left-hand side of this interface, there's a tree view which shows all the information available for the job, and that's mirrored by the tabs along here. And there's a folder listed as time series on the left-hand side, which lists all the time series information we have for the job. So if I click on the CPU user, it will bring up a plot showing the CPU usage. Now, at the bottom of this interface, there's a description that explains exactly what this statistic means. And when we hover over the plot, the hover over seems to not work. Strange. So usually when you would hover over this, you would get a little dialog box that would come up that would show you the overall CPU usage information, and click on it. But so it must be the way that the sharing is working on this that isn't working. Strange. You can also use the tree view on the left-hand side to navigate the plot. So what we're showing here is the CPU usage over time for all of the different compute nodes in this job. And this job, you can look on the accounting tab, used 16 compute nodes across 128 cores. So this is a plot showing all 16, the average CPU usage on all 16 compute nodes. And the obvious thing from this is that there was during the first few hours of the job, there was some CPU usage. And then during the latter part of the job, all the CPU usage dropped off to 0. We can actually click on the left-hand side and view an individual compute node and look at the individual cores on the given compute node. And again, not too surprisingly, it sort of mirrors what we saw before. So there was some CPU activity during the first couple of hours of the job, but then a significant chunk of time where there was no CPU activity. And we can also look at various other metrics. So this particular job, we have information about the interconnect traffic. So the interconnect traffic, interestingly enough, mirrors the CPU usage. So a decent amount of several hundred megabytes a second of interconnect traffic for the first couple of hours of the job, and then nothing. There's a L1D load ratio, which is roughly speaking, it's a very cautious measure of the amount of useful work done, because if you're pulling information into the L1 data cache, then you're pulling new data in that's being processed by the core. And as you can see, during the first part of the job, it's doing something and there's nothing going on. We can look at parallel file system traffic, how much activity there. In this case, we have memory bandwidth statistics as well. So, and memory usage statistics as well. So there's various different charts available.
Hey, Joe.
Yeah.
Do I remember seeing, and maybe it's under executable information, that it usually has the submit script that the user used as well?
Yeah, so in the, for the XSEDE resources, we don't get the launch script, but in the open source version, we have the infrastructure in place to collect that. So for example, at our center, we collect the job launch script, and that actually shows up as another tab in the interface. So yes, that's available for the open source version. It's not a data source that we have access to in the XSEDE version, but if we had access to it, it would be in here.
Okay, got it, thanks.
So the other information, so executable information. So in this case, we collect this by looking at the process list while the job was running. There's the accounting data tab, which shows information about the job broken down by different things. So for example, this job ran for nearly 8 hours, requested 12 hours, you know, that's not too bad. Used 5 and a bit node days of node time and 41 days of CPU time, of which probably more than half of that was no CPU usage. Anyway, so just very quickly showing you the different types of information that's available for the different jobs. And the idea again here is that you can use this as part of the support thing. So when you get an information request in from a user, you can have access to what was going on in their job when it was running, which hopefully can give you more information, which can aid the debugging and process. So there's a couple of nice things that you can do here. If you view one of the plots, there is on this toolbar at the top, there's an export button. So for example, you could export the plot of the CPU usage, click on the export button. There's a dialog box with a drop-down list of different export formats. We can export this as a PNG plot. That will then download a PNG graphic to your computer, which you could then, for example, email the user if you wanted to point out a specific feature. You can also, on the tree on the left-hand side, if you right-click on the job itself, you get this job actions dialog box, and you get a shareable link menu option. When you click on that, you'll get a dialog box pop up with a link that you can then email folks. And when they click on that link, it will take them to the XDMoD interface. If they're not logged in, it will prompt the login dialog box, and then it will take them to the job viewer showing that job. So for example, you could email the user that's asking for support and show that and get them to look at the interface as well. Now, I'll just point out that this link doesn't change the access permissions on the data. So if their user account can't see that job because they don't have permissions, that link isn't going to get them to the thing. It's just going to pop up an access denied message. But for example, if it's the user that ran the job themselves, they will already by default have permissions to see their own jobs.
So Joe, they don't have to be sitting right next to you then, right? Or if they send that link to you?
Yeah, that link, you send that link by email, and then that works. That will go straight in. What was the other information I was going to show?
How the tooltips work?
Yeah, so just an example. So as I mentioned before, you have the tooltips on the top, the question marks for the analytics boxes, but all of the different metrics that are shown in all these tabular information, if you hover over it, it will give you information about exactly what that metric means. So for example, on Comet, there's a shared queue, and if the job ran shared with other jobs, then it will be set to true there to show you that there's other stuff going on at the same time. Right. Okay, so another way that you might use the job viewer interface, you can use a search, so you can find jobs that you know about already. But for example, if you had a user support request and you wanted to see what other jobs that user had been running in the past, you can easily search for any given number of jobs by a number of different criteria. So I brought the search dialog box back up, and there's the advanced search pane on the bottom left of this dialog box has options to specify time range, and then options for a variety of number of different filters. And the filters are sort of grouped by different things. So administrative information such as who ran the job, what resource did the jobs run on, who was the PI, what NSF directorate were they in, what field of science was their allocation assigned to, what application did the job run, what was the CPU usage of the job, or what was the memory usage of the job, or how big was the job, how long did it run, what queue did it run in. So just show an example. So you can select filter by user, and I'm just going to select the our TAS community user. So what I did there was I clicked on the filter, selected user, and then you have the dialog box. You can type into that to reduce the number of options available, or there's a big drop-down box that you can scroll through. So a combination of starting to type, and then when you get closer enough, you can click on it. And then you click search, and then this should bring up. So this is now bringing up the list of all the jobs that our community user account that we use within the XDMoD project has run for XSEDE jobs over the last couple of weeks, so end of August until present time. And just listed by job ID and resource. And what you can do is you can click on a handful of these jobs, and there's a little tick box here that shows up. Just click a few of these at random, and then click Save Results. And then all of the ones that you selected show up on the tree in the left-hand side, and then you're free to click on them, and then it will bring up the job in the interface. So a couple of things I wanted to point out here. So depending on the HPC resource that the job ran on, we have different metrics available. So in the case of Stampede 2, we don't have the homogeneity metric, which is the reason why it says it's not available. And we also have access to slightly different time series information. So there's no L1D load rate metric on Stampede 2. And similarly on bridges, we have access to different information as well. It just depends what the resource provider is providing us. Now, so we've listed a whole load of jobs for a given user, but you might want to filter down slightly more. You can actually go back to the search, right-click on it, and edit the search, which will bring back the search dialog box again with all of the criteria that you used, and you can add more criteria. So, for example, let's restrict it by job wall time, and we're just looking at the jobs that ran for between 1 and 5 hours. Click on search again. There's only a couple of jobs in this case. I can select them both, click Save Results, then it updates the tree, and now we're just looking at jobs that ran by our community user that were between 1 and 5 hours long.
There was a
we
question.
Can bring up that information.
As XSEDE members, we can access XDMoD to find information about jobs run on XSEDE resources by users from our institution only, correct?
Yes, as campus champions, yeah, I believe that's the way that we do the access permissions, yes. So depending on, so the software itself has a sort of fairly fine-grained access controls. By default, you know, you only get to see your own jobs. PIs get to see their jobs and the jobs for their allocation, so for all their students. Then the campus champions, we allocate whatever campus you're associated with, you get to see users' jobs for that campus. Center directors for a given HPC resource get to see all the jobs for their HPC resource, so the TAC center director gets to see all the Stampede information and you know, and all the other ones. And then the program officer gets to see everything. So that's the way we do the access credentials. And then in the open source software, it's a similar hierarchy, although not quite as fine-grained. So the open source version just had user, PI, and then center staff.
Can I continue the question briefly?
Yep.
What I was trying to find out, so if we wanted to use the open XDMoD at our own institution, we would set it up, right? So that we can get the information out that we want? Yes, yes.
Okay. So you go, so there's two parts of it. So there's the open XDMoD server that will ingest all of the job accounting data from your HPC resource. Okay. And then there's the instrumenting your cluster with some data collection software to get the job performance information. So those are two things, both of which you would need to do if you wanted to get the full job performance information.
Thank you.
And then at our center, we have our cluster instrumented with Performance Copilot. We run Slurm here, so we also ingest the Slurm logs into our open XDMoD instance, and then we have all the different things set up. We have it integrated with our single sign-on so that all of our users can use their normal UB credentials to log into the interface.
Okay, thank you.
Okay, so that was a very quick overview of the things that you can do and the ways that you can find jobs in the job viewer, and very brief overview of the types of information that's available in there. I think we're now going to change tack a little bit and then show some information show how you can look at some of the aggregate information that's available in the interface. So I've just clicked on the Metric Explorer tab, which is on the sort of top left of the interface, and this allows us to view the aggregate information in chart form in XDMoD. So on the left-hand side, there's this thing called the metric catalog, which shows information groups basically by the type or data source of the information. So accounts is accounting information that, because this is the XSEDE information we get from the reference data from the central database. Allocation information from the XRES, I believe. Jobs, which is the accounting information from the central database. Requests and resource allocations, and then Supreme, which is our name for the job performance data. So I could very just quickly, you can untick the box and show all the list of information. I'm just going to look at the jobs realms. This is all the accounting data for XSEDE. We can look at, say, I don't know, CPU hours total. So click on CPU hours total, and then you have the option to group by different ways, and I'm just going to click on group by non. So this is just showing the overall CPU hours running on all the XSEDE systems. By default, it's the duration, which is in the top left, is the previous month. So this is the time series plot showing the number of CPU hours in total for XSEDE over the month of August.
Can you show how easy it is just to change to a column view real quick? Or?
Yeah, actually, I'll get to that.
Okay.
I'll get to the thing. So I suppose from the point of view of a campus champion, you're probably more interested in the users of your campus. You can add, there are different filters. So on this toolbar on the top, there's this add filter button, which lists all the different filters that are available. I'm not going to go into all of these in detail, but there are things like the size of the job, or the type of the grant that the job was running under, or the resource that the job ran on, or the institution of the user. So you can filter by user institution, and you're presented this dialog box. There's nearly 1,500 different user institutions in here. There's a search dialog box that you can use. Type in the search dialog box to filter down. In this case, I'm going to pick University of Michigan for want of anything better to speak. Nothing's necessarily unique about this, but click OK, and then that adds a filter to the data. So now what we're looking at is we're looking at CPU hours total for XSEDE, but for users that were at University of Michigan. So this plot is interactive in that you can hover the mouse over to it, and you get a little tooltip over there that shows you the exact count of the numbers for each given thing. This is a plot over the last month, so this is daily plot, so this is the number of CPU hours per day. You can click on the title at the top and edit it, so we can change this to like CPU hours. Just to give it a more meaningful title, and by default it will populate a subtitle showing the filters you've added, so you can keep track of what's going on. Couple of other things, there's undo buttons on the top here, so if I've made that change and I actually decided that I didn't want to do that, I can quickly revert that change or redo and reapply the change. And then a save dialog here to make sure I commit the changes, so that next time I log in, this chart will be present in the menu. And that chart actually gets shown up in this load chart menu and will show up on the under the menu. So I know I could change the time range to be, say, year to date. So show the information for over the last, show the number of CPU hours for University of Michigan since the beginning of the year. By default, when you change the time range, it chooses a time period that's most appropriate for that time range. So I'm showing now the data in monthly view. If I really wanted to look at different aggregation units, I can click back on the duration toolbar and then are presented with an option to specify different aggregation units. And you can use a daily aggregation unit for shortish time periods. So if you want to do 10 years worth of information, you can't use by day, but can for shorter time periods. This plot is interactive, so you can drill down and group by this information by different ways. So for example, we could group by the actual users on the system and show the actual usage for different users on the system. Now, this in a time series view isn't necessarily sort of the best way to present this information. So what we can do is we can change and actually view in aggregate form. So what I did there is on the top right hand side, there's a toolbar. Click on that and you can change the data set type and toggle between aggregate and time series, as well as a whole load of different other options on there as well. And line plot isn't very good for aggregate data, so we can also change that by clicking on the plot and change that to a bar plot. And while we're at it, we might as well swap this between an XY plot so that the information is presented a bit more clearly. Now we have a bar plot showing the top 10 users over the last year who are from Michigan, and the number of CPU hours that they've used on XSEDE. Now, on the bottom of the plot here, there's different options. So there's actually 130 different users, and we can page through that data. But we can also tick this box that says show remained and disable paging, and then it will average the other users. So now what we're looking at a plot is the top 10 users plus the rest of them. And hopefully it's obvious that the average of the 120 is a relatively small number. So this is a fairly long tail with, say, the top top handful of users using most of the hours of the system, and then a long tail of the smaller number of users. So we think this information might be useful as you as a campus champion for knowing who is using the system, who are the large users of the system that you're responsible for helping. Can save this chart, and what we can do is we can make this available for report. So there's this tick box that says available for report. You click on that, and then that saves this chart and makes it available in the report generator interface. The report generator, you can get that by clicking on the report generator tab, which is about in the middle of the tabs at the top. And in this interface, there's a list of available charts that show on the right-hand side, and all the charts that you've ticked available for report for show up. So on the right-hand side here, the one at the bottom is the chart that I just created. This chart above is a time series chart that I created earlier. And how do you create a report? There's this My Reports. You can do new report, and then there's some information you can do in, such as give it a title, give it some header text and footer text, decide whether or not you want 1 or 2 charts per page. And then the main interface that allows you to drag the available charts into the interface and move them around. So you just drag click on the chart, hold the mouse button down and move it across into the middle. I can do it for both of these charts. If I want to change the order, then I just drag them around and then change the chart order like that. If I decide I don't want one of these charts, I can click remove. If I want to view zoom in on the chart just to check that it's actually displaying something sensible, then I can click on the little magnifying button on the bottom right hand side. If I decide that I want the time frame to be changed, then I can change this to say always show the previous month's worth of data, or always show the previous quarter's worth of data, worth of data, by clicking edit time frame. Then I save that chart, and then if I want to view it now, I can click download that as a PDF or as a Word document. But probably the most useful thing is being able to schedule the report to be generated on a periodic basis. So on the scheduling thing on the bottom left-hand side here, you can say I want this information to be sent to me monthly via email as a PDF document. Save that information, and then you'll get that information emailed to you every month with those charts, and the time frame will be updated every month, so it will be kept up to date. And if you do it as a Word document, then you'll get something that's editable if you wanted to cut and paste into a report to report to other staff, or just keep an eye on different things.
There's a quick question in the chat box that says, is there an alert feature that can send an email or notification when someone reaches a certain threshold?
Not as of present time. However, that is something. So in our roadmap, we have user. What are we calling it? It's like the user report thing where, yeah, okay, so no, but we do have the planned thing that's in our roadmap of being able to have alerts or have reports sent based on other criteria happening, such as when users reach a certain threshold of like poorly performing jobs. I'm not explaining this very well, am I? We're trying to.
Well, the idea was more to do a periodic report rather than, you know, something that's an alert that really triggers a threshold.
Yeah, but I mean, it would only send data if there's data to be sent. So
yeah. Okay. In that sense, yes.
So actually, so that brings up a useful thing which I hadn't mentioned now. So we have on the top right-hand side, we have our roadmap. And if you click on the roadmap information, it shows it actually brings up the About tab and shows the roadmap. And this is actually an interactive tool. We use the Trello software. And what you can do is, if you have a feature that you're interested in seeing, by all means tell us about it. Because if we know that folks want these things, we can add it to our list. And then periodically we go by and decide exactly what we're going to prioritize. So the roadmap tab shows what our current priorities are. In fact, actually, if you look here, I've got track GPU usage is on the roadmap for the November release. Referring to that question that was earlier. But you can go to this and you can actually, if you want to click on it and you want to say, well, yeah, I'm interested in tracking GPU usage as well, you can actually like vote on it. There's a handful of folks that have voted for that already. In order to use this interface, you have to sign in, but you can sign in using a single sign-on. So you just use your existing credentials to do that, and then you can vote on the different things, or even suggest ideas about what you think we should put on our roadmap. Just mention that. Okay, so going back to the Metric Explorer, I've just been showing the job accounting information here. Just wanted to very quickly, in the last sort of few minutes, just show some of the other types of information that we have in the interface. Now, you can actually generate plots with from multiple disparate data sources. So you can look at the accounting information and the performance information in the same plot. What I'll do is I'll create a new, let's say a new aggregate bar chart. Give it a name, and then from the metric catalog, I'm going to select let's just select the number of jobs ended, but grouped by the CPU user value. So this is 1 second when it loads, going to show the year to date of the CPU efficiency of all the jobs in XSEDE by number of job count. So the bar plot, I can click on this. There are various different options to manipulate this data. So I can do things like I can change the sort order, use a native sort order. I can change the way that we handle remainder. I can change the number of data points that are shown. And basically what we have here now is a histogram type plot showing the CPU usage across all of the XSEDE resources. So by job count at least, you know, a decent chunk of jobs have over 90% CPU usage. There's actually a sizable number of jobs have less than 10% CPU usage overall. And then we have a decent number of jobs that we don't have CPU usage information available for. That's usually because either the job was so short that we didn't capture that performance data, or the provider itself didn't provide that, the resource provider didn't give us that information.
You should mention that on XSEDE, it's every 10 minutes.
Yes, yeah. So it depends from it depends on the different things, but the providers that are using TaxStats have so Stampede 2 uses 5-minute collection period. Comet uses a 10-minute collection period. As I say, it varies from resource provider to resource provider what information we get. We can add filters for the information. Let's just change this to a slightly shorter time range, just use like a 30-day range or something. And we can add filters to like filter by different resources. So, you know, if we just wanted to look at the information from bridges or something like that, then we could do that very easily and look at the distribution for bridges. And if we only wanted to look at the exclusive jobs that ran on bridges, ignoring the shared jobs, then we can do that as well. And you look at the different distributions. So why would you be interested in this stuff? Well, one of the sort of use cases we're thinking of is that you can now drill down on this information and get down to the individual jobs that fed into this data. So you can drill down on a given plot by clicking on a given bar and say drill down to the job wall time. So now we're looking at the exclusive jobs that ran on bridges that have less than 10% CPU usage. So there's a handful of jobs there that ran for like over 18 hours with very low CPU usage. We can drill down again and look at say the job size, and we find that actually almost all of those jobs were in a given size range. And you can click on show raw data and actually get down to the individual jobs themselves, click on them, and then get straight through to the information in the job viewer about the given job that fed in. So here's the CPU usage for that job over time, and I guess it looks like it's quite low. So anyway, the idea is that so the tools are available to do not only react to user support questions about help for jobs that they've run, but also proactively go in and use the tools to find jobs based on different criteria that have noticeable characteristics that you can then investigate and say, well, is this sensible? Oftentimes, you know, this tool doesn't tell you all the information you need. There may be good reason why a job has low CPU usage if it's an IO intensive job or if it's a memory intensive job, but this gives you certain tools available to you to add to your information available to you.
Yeah, I think approaching an hour.
Yeah.
So I think that we just wanted to be respectful of an hour, and we're happy to stay longer, but that just gives you hopefully a pretty good overview or general overview of the utility, particularly as it applies to the job viewer, and detailed information about every job that runs on the cluster. And as Joe mentioned, you can do it both for XSEDE, and if you install OpenXDMoD and Performance Copilot on your own cluster, you can obtain that information for your own cluster. But we're happy to answer any other questions, or we also, if people are interested, we can give more detailed institution-specific demos and tutorials. We're happy to do that as well.
This has been really great, Tom and Joe and the rest of the Buffalo team. I know we've had a lot of references to XDMoD and the Campus Champions mailing list and during informal meetings and things. So I'm really happy that you guys were able to take the time to present this to our group. And hopefully I don't see any more questions popping up, but I would certainly encourage everybody, if you have a specific use case at your institution, or if you would like to provide insight or additional roadmap items to this project. You know, this is one of the few that I generally don't go for GUIs and things, but I fell in love with this thing as soon as I saw it. You know, it's always been from a center director perspective, it's always difficult to convey what your resources on campus are doing to your administration. You know, so the provost, the deans, you know, they don't want lots of numbers and things. They want a quick, as Tom mentioned, the director's overview or something, and and this thing is just invaluable for that type of report, and it makes it very easy to aggregate your year-end reporting for your center and things too. So there's just a plethora of reasons to adopt this thing, and it I certainly haven't seen the negative side of it yet. I can't get the Buffalo guys to tell me what that might be, but I certainly haven't found any negatives to this as of yet. It continues to grow and evolve, and I'm anxious every time a new version comes out. So anybody that has a quick question or anything, please catch the guys while they're online.
And Jeff, the only thing I'll add to that is if you're interested in installing it at your center, we're happy to help with the install, and we're pretty responsive to that. And the base version, the Open XDMoD without the job level performance metrics or the application kernels, you can install within an hour or so. And then you have to shred the log files and do those sort of things. And then installing the job level performance Supreme module and application kernels is you don't have to do that. But if you do want to do that, it's a little bit more work, but we're happy to help with that too.
Yeah, so we, just to reiterate, so we have the, in addition to going into the user interface, clicking on that contact us button on the top right hand side, you can also email us directly, which then goes into our ticketing system. That's ccr-xdmod-help@buffalo.edu. And we also have a mailing list, the link for which is on our open.xdmod.org site, which is the main website for the open source project.
Excellent. We really appreciate this. I hope, I suspect that there were a number of champions on the call today. They're probably already XDMoD users, so this served to show them some of the finer features of the product. And I also expect that those that aren't already running XDMoD probably saw a lot of things they liked. So I would expect some additional questions and contacts from this large group in the very near future.
And the last thing I'll mention is we're in the process of coming up with a novice type version of the interface, because we had quite a few requests that there is the interface is pretty powerful and you can do a lot with it, but when you do that, there's a fairly steep learning curve. And so we're coming up with a view that's we consider introductory view, and it'll depend on what sort of your role is. If you're a user, a PI, an HPC support specialist, center director, but it'll be easier to use interface view, and that'll allow you to quickly become acclimated to Open XDMoD. And then the idea is that as you become more familiar with it, you'll learn some of the additional features. But we want to try to lower the activation energy to start using it immediately, and we've come up with a way to do that, and we're in the process of figuring that out. We hope in the next year to have this much more novice view released.
There's a quick question in the chat box saying that the person missed the answer on the GPU usage tracking. Can you reiterate the answer to that question?
Yeah, so for the open source software release, we're planning to have the sort of full-fledged GPU usage information in the release that's coming out in November. So that's what's currently in the roadmap plan. At the moment, if you were to download and install the currently available software release, you would get GPU usage information available as a time series plot in the job viewer. So the way that we're doing the GPU usage information is if you have your cluster instrumented with PCP, there's an NVIDIA monitoring tool in PCP that gets the statistics from the NVIDIA driver. So the caveat being that we're only supporting, or we only are aware of data collection software that collects stuff from the NVIDIA chipsets, but I believe that's the most common chipset anyway. And that collects information like GPU usage and GPU memory usage. So that information is currently being collected. If you install the default settings that we recommend, you'll currently be collecting that information. But the pieces of the plumbing to get that as a metric in the Metric Explorer haven't been done yet, and we're planning to get that done by the November release.
Great, thank you. Would you gentlemen mind sending me the slides and links, the appropriate links, so that I can send that out to the community as well, along with the recording?
Yep, we'll maybe add those. We'll add the links to the end of your slides. So,
okay.
Yeah.
Right.
Super.
Thank you.
All right. Okay.
We certainly appreciate it, Tom, Joe, and the rest of the Buffalo gang. we will definitely be in touch. And we had a really good turnout for the call. At one point, we were at 50 participants. So I think it was a great turnout, and it's obvious that everybody's really interested in your project.
Well, we're thankful for the opportunity. Always happy to do this.
Okay.
Awesome.
Thank you, sir.
Thanks, everybody.
All right. Take care, everyone.
Bye. Thank you.
Bye.
Bye.